Hello everybody. Now we're going to look at section 13.5, the fundamental theorem of calculus. In the fundamental theorem of calculus, if you've got a function and it's continuous, but it's defined on a closed interval from a to b, and capital F is the antiderivative of f, then what this statement says, notice this is a I've got a definite integral here. I know my left value, my right value, because that was given by the closed interval. If I can do the antiderivative, once I found the antiderivative and I substitute these values individually into it and take the upper limit minus the lower limit in my antiderivative, I find the area. Now earlier when we were looking at this, I don't know if you remember, but if you take a capital S, say right here, this S in my section, and if you could grab a hold of the ends and pull, then it would elongate to the integral sign. And technically what's going on here is I am summing up hundreds and hundreds and hundreds of rectangles. Remember, f of x, y is the height of the rectangle, the dx is my width. So I am summing up all of the rectangles, bunches of them, from A to B to give me my area. Everything that you have done in the past, really you've got all the ingredients here to do these problems. Steps you need to use to complete the fundamental theorem of calculus: integrate the given function. So go integrate, that's your first job. Second, substitute upper limit, lower limit, and you subtract those values. I have some examples here, and then I'm going to show you something by calculator where you can check yourself. So I have a definite integral, lower limit 0, upper limit 2, of x cubed dx. So for my first job, I've got to go integrate. Coefficient is 1. I've got to add 1 to my exponent, repeat, plus c. I will use a vertical line indicating that I have integrated and I know what my upper and lower limits are. Now once you integrate, your next job is to substitute. So if you substitute 2 in for x, here's the first part. Second part, substitute 0 in, and I usually do that with a parentheses if I'm doing it particularly by hand. And then clean up. 2 squared is 16. 1/4 of that would be 4, plus c, minus, this gives me 0 plus c. So in the parentheses, all I have is a c. I'm going to do the opposite, and my c's will eliminate, and it gives me 4. Now this will be the only time you will actually see the capital C, that constant of integration, because it's always going to cancel itself out. So when I have a definite integral, I've got these limits, you'll not see me put c anymore. This is it. I'm not going to do it again. Let's look at this problem. I have got 6x plus x to the 1/2. Start the process. I'm going to have 6 over the fraction bar, add 1, so I'm going to have a 2 here, divide by 2, so I should have 3x squared. There it is. Now x to the 1/2, well, my coefficient is 1, so when I add 1 to my exponent, I get 3/2. Now if you go 1 divided by 3/2, put the 3/2 in parentheses, and go frac it, you'll end up with 2/3. Now I've got to go from 1 to 2. Let me get my calculator and see where these values come from. First, I always do the upper value. So 2, store in for x. Type in what our antiderivative was, 3x squared plus 2/3 x raised to. Now if you put in 3/2, you'll need parentheses, but if you put in 1.5, you won't. So there's that 13.8856. Let me store in 1. I'm going to recall that last function. I don't want to have to type it in again. So do second enter, now hit enter. So there's that piece. So now I've got to go this minus that. So 13.8856 561808 minus, let me recall that answer, so second answer, and there's my 10.219. Very nice. I'm going to show you something how to check yourself graphically on the calculator, and it's really cool because you get to see shading and everything. I need you to go first to y equals, type in the original, because remember I'm saying I want to be able to check this, so I want to do it a different way. So let me type in 6x plus square root of x. Okay, let me do my zoom 6. There it went. I'm going from 1 to 2. Now, anytime I want information from the graph, I'm always going to do second calc. Do you see number 7? Hit 7. My lower limit was 1. Enter. Upper limit 2. Enter. You'll see the shading. And there's my approximation. Now these steps, what I just did, are on the next page, so don't write this down. It's here. You just don't have to write it down. Let's go look for another problem. Number 3, you have to separate. You might try that one. Ooh, let's try number 5. It's one of those E's and LN thingies. So first thing I need to rewrite, I need to see the exponents. So remember with the E, take your constant, that's 1. Rewrite the e to the whatever, get the derivative of the exponent, minus, my constant here is 2, over natural log. Remember we put in absolute values. The derivative of that inside is 1. And I usually do a little bit of cleanup. Not much I could do except 2 over 1. And now we substitute in. Let me get my calculator back. Quit this. Let's clear it off. So let me put in 2, storing for x. Enter. Type in this part because once we integrate, we first put in our upper limit when we do it by hand minus our lower limit. I need to move this a little bit so we can see. So let's type in 0.5 second ln to the 2x minus 2 natural log. Now you don't have to put absolute value, it pretty much understands that. Unless we have to put in negative numbers, it's a different ball game, but we won't have to. So let's see if we get that 25. So there's that part. Now let's put in 1, storing for x. Let me do second enter to recall. So there's that piece. So I'm going to take the top one, 25.912788066 minus my second one. And there it is rounded off. Let's try graphically. So put in the original. Second ln 2x minus 2 divided by x. Let me ask it to graph. Okay, we're going from 1 to 2. So remember, I'm going to do second for trace for the calc menu, hit number 7. It will ask you for your lower limit, which is 1. Hit enter. Upper limit 2, and let the shading begin, and that should jive with your answer, which it does. So you've got some problems here to practice with, not only by hand but also graphically. So try those and see how they go. Thank you. Bye-bye.